All right, guys, so we're going to talk about solving 3 by 3 systems of equations today using elimination. So the same elimination slash linear combination method that we talked about with 2 by 2s. But in a 3 by 3 system, we're going to have 3 unknowns. And remember, important concept we talked about, if we had 2 unknowns, we need 2 equations to find an exact solution if one exists. So same idea, if we have 3 unknowns, we need 3 equations relating them to find an exact solution if one exists. If we had 4 unknowns, you'd need 4 equations, etc. Okay, so kind of with our other systems, there were kind of a couple different possibilities. We may have had infinitely many solutions. In a 2 by 2 system, that was when we had coincident lines, or the same line on top of itself. We had no solution when we had parallel lines. The lines never intersect. And then we had one solution when our lines intersected. So this time in our equations, we're going to have x, y, and z. And you don't have to worry about it too much, but when we're graphing those are actually planes or flat surfaces in space. And that does relate to these different things, the way the planes intersect or don't intersect, and if there's exactly one solution, etc. We're not going to worry about the graphing part of this. We're just going to work on solving it. But with x, y, and z, we write our answer as an ordered triple. X, comma, y, comma, z. Just like when it's an ordered pair, x and y, this is how we write when we're graphing stuff in three-dimensional space, a three-dimensional point. Anyway, we're not going to get into the actual graphing of three-dimensional, etc. We're just going to solve these. But we have those same 3 possibilities. There could be one solution, infinitely many, or no solution at all. Okay. So remember, using elimination in a 2 by 2 system, our goal was to set up the variables in such a way that when we added or combined our 2 equations, that we eliminated one of our variables. And then we got down to one equation with one unknown, and we got to solve for our first unknown. In a 3 by 3 system, our goal is to eliminate one variable twice and create a 2 by 2 system. So 2 equations with the same 2 variables. So let's say if we eliminate z, I'd have an equation with just x and y, and I'd need a second equation that has just x and y. And then I can solve that 2 by 2 system like we did before. Okay, let's take a look at an example. Okay, here's an example of a 3 by 3 system. We've got 2x plus y minus 2z equals negative 1. 4x minus 2y minus z equals 5. And x minus 2y plus 3z equals 6. Okay, so pause the video if you need to write that down. Okay, so in this example, first thing I want to do is look at the 3 different variables we have, x, y, and z. And my goal again is to chop this 3 by 3 system down into a system of 2 variables and 2 equations. So I want to figure out which variable is going to be easiest to eliminate twice, because remember I need to create 2 new equations with just 2 variables. So my x's I think I could make meet at different places pretty easily, either at 2 or 4. My y's I could make meet all at 2 or negative 2. I like that. That looks pretty easy. And then my z's I could make meet at like 6 or 2 or 3, depending on what pairings I do here. So one of the first things we always want to do, because there's going to be a lot of steps when we go to solve this system, and it's hard to sometimes follow what somebody's doing, is we're going to label our rows. So we label this row 1, row 2, and row 3, or equation 1, equation 2, and equation 3. Just so we can kind of notate what we're doing with each of these. So let's say I want to eliminate y. I think y was a pretty good choice. And let's say I want to do the first 2 equations together. In order to get my y's to cancel, I could make them meet at 2. And I've already got a negative 2y, so let's make this positive 2y. So what I need to multiply everything on both sides of this equation by 2. Okay, so the way we do that is we're saying we're going to take equation 1 and multiply it by 2. Okay, and then we're going to write our new equation next to it. So this is 2 times equation 1, multiplying everything by 2 in there. We're going to get 4x. Oops, this didn't change colors. All right, there we go. 4x plus 2y minus 4z equals negative 2. Okay, so all I did was double everything up here. 2y, negative 4z, negative 2. Okay. Underneath that, we're just going to rewrite equation 2. And then eventually we're going to add them together. Okay, so I'm just going to rewrite equation 2 underneath it, just so they're nice and lined up. 4x minus 2y minus z equals 5. And we're going to add these two together. So that gives me 8x. My y's cancel. And that's what I wanted to do. Minus 5z equals positive 3. And what we did is we created a brand new equation. So we should label our new equation. We already used 1, 2, and 3, so we'll call this equation 4. But I have a new equation that has just x and z in it. So I have two variables. Remember, I need two equations with x and z to solve this. So I'm going to need to do another pairing up here. We did 1 and 2 already. So my other options would be 2 and 3 together or 1 and 3 together. But my goal would be to eliminate y. I actually like equation 1 and equation 3 as a pairing, because again, I could make this double these numbers and add it with equation 3, and my y's should cancel out. So actually, we can use that same equation we just did, 2 times equation 1. And that's going to make this positive 2y so that I can cancel my negative 2y in equation 3. So I'm just going to rewrite the numbers here. I know we already did this a second ago. 4x plus 2y minus 4z equals negative 2. So it's the same equation we got here. But this time we're going to add equation 3 to it. So we're going to do plus equation 3. And we didn't have to modify equation 3. We'll already have a negative 2y. But I have x minus 2y plus 3z equals 6. So this is just the exact same as equation 3. All right, and we're going to add these together. 4x and x makes 5x. My negative 2y and positive 2y cancel. And I end up with negative 1z equals positive 4. So I didn't mention this earlier, but do something to make sure your z's don't look like 2's. I don't know why that really confuses students. Sometimes their own handwriting confuses them. So I like to put a slash through my z so it never looks like a 2, and I always remember it's the variable z. Do something. Either make your z's really sharp with really sharp edges like this, and then your 2's a little more curvy, or something, just so you never make that mistake. All right, but I have a second equation now that has just x and z. And I created a new equation, so let's call this equation 5. And my goal now is I want to use equation 4 and equation 5 as a system of equations and solve this 2 by 2 like we did in our previous section, solving 2 by 2's by elimination. And if I want to cancel these out, I could make my x's meet at 40 and negative 40, or my z's meet at 5 and negative 5. And I think that's the better option. So to make these meet at 5, I've already got a negative 5z. I want this to be positive 5z. So we're going to need to multiply this by negative 5. So let's notate that. I'm going to do negative 5 times equation 5. And we'll write our new equation over here. So my new equation, when I do that, I multiply this equation by negative 5. Negative 5 times 5x is negative 25x. Negative 5 times negative z makes positive 5z. And 4 times negative 5 is negative 20. Okay, underneath that we're going to put equation 4. I'm not going to modify equation 4. I don't need to modify equation 4. So we're just going to rewrite it underneath it so that everything's nice and lined up here. 8x minus 5z equals 3. So I'm just copying this equation. And we're going to add these together. Okay, so this time our z's will cancel out. Let's see, what is this? Negative 17x equals, and adding these together, negative 17. And if I divide both sides by negative 17, we should get our first coordinate. And this is good, actually. The fact that we got a solution here, and we didn't get one of those weird cases where all the variables canceled out, that does mean, going back to that first page, that there is one solution. So as long as I get a variable, we don't get one of those weird cases where everything cancels out, then there is a solution. In fact, we've got the x coordinate. Okay, I now know x is 1. In order to get my next variable, though, I need to go back to either of these 2x2s, or either equation that has x and z. So I could use equation 4 or equation 5 that I created to help me find z by substituting in 1 for x. So I like equation 5. I think it looked a little bit nicer. So let's use equation 5 and substitute in. We've got 5 times x minus z equals 4. And we're substituting in that answer of 1 to help us solve for z here. So 5 times 1 is 5, minus z equals 4. Subtract 5, negative 1z equals negative 1. And if you divide each side by negative 1, we get z is positive 1. Well, yeah, those are some pretty nice answers so far, 1 and 1. Okay, the last coordinate I need is my y coordinate. And so I need to go back to an equation that has y in it. I already have a value of x and z I can substitute in. And I can pick either of these 3 equations to plug into. I like equation 1 because it's got positive 1y, and it's got nice simple numbers. So let's use equation 1 to plug back into. So we'll use equation 1, just notating which equation we're using here. 2 times x plus y minus 2 times z equals negative 1. And so we're substituting in our values. We're going to plug in 1 for x and 1 for z. I know I'm creating lines everywhere. You don't need to do this on your paper. It's just hopefully so you figured out where those values came from. 2 times 1 is 2 plus y. Negative 2 times 1 is negative 2. Combining our constants on this side, actually 2 and negative 2 make 0. So they kind of cancel each other out when I combine my like terms. And I end up getting that y is negative 1. So my ordered triple, if I have this right, is 1 for x, negative 1 for y, and positive 1 for z. So that should be my x, y, and z triple. We can check this in our calculator. So we did this the other day. We had our, in our scratch pad, we went to menu, algebra, solve system of linear equations. This time there's 3. And notice actually by just clicking down here, after I clicked 3, it even filled in that the third variable is probably z. And so we can type in those 3 equations. I'll use my keyboard here. 2x plus y minus 2z equals negative 1. 4x minus 2y. I'm just checking our solutions here. Minus z equals 5. And x minus 2y plus 3z equals 6. And hopefully that's it. There's our solutions. 1, negative 1, and positive 1. All right, so far so good. We solved one system. As you can tell, it's pretty time intensive and there's a lot of little steps where you can make mistakes. So you really just have to be patient with them. And there's not a million problems in your homework, so just be patient with the ones that you have. Take your time. Try not to make all those little silly mistakes. So we've got another system here. Once again, I'm going to label my equations equation 1, equation 2, and equation 3. We put those in circles just to know that's not what we're multiplying by. Those are equations. And this time, again, I've got 3 equations, 3 unknowns. I want to get down to a system of 2 equations, 2 unknowns. And what I see right away that I like is I already have an equation with just y and z. So if I can get a second equation that only has y and z, I have a 2x2 system and I can finish solving that. So I think my goal here is going to be, I want to combine 1 and 3 in such a way that I can eliminate x. And I could make them meet at 6x, but I need one to be positive 6x and one to be negative 6x. Whichever you choose to be which doesn't matter, but I definitely need to make them meet at 6. So let's see. Let's do I'm going to do the top as positive 6x. So I need to multiply equation 1 by 3 everywhere on both sides. So let's notate that. 3 times equation 1. Okay, so let's multiply everything up there by 3. 2x times 3 is 6x. 2y times 3 is 6y. 3 times 5z is 15z. And 20 times 3 is 60. Okay, there's 3 times equation 1. I also want to do, make this negative 6x. So what am I going to need to multiply this equation by to make this negative 6x? Is by negative 2. So we're going to take equation 3 and multiply everything by negative 2. So 3 times negative 2 is negative 6x. Negative 2 times negative 2y is positive 4y. Negative 2 times 9z is negative 18z. And negative 2 times 36 is negative 72. And we're going to want to add our answers together, combine these equations. So my x's cancel, which is what I wanted. We end up with 10y minus 3z equals negative 12. Okay, and we created a new equation. We'll give it a number. Let's call this equation 4. Okay, so I have 2 equations now that have 2 unknowns. Equation 2 and my new equation we created, equation 4. And so I need to solve this 2x2 system. If I wanted to eliminate my y's, I could make them meet at 10 and negative 10. Be our least common multiple there. Or my z's I could make meet at 12. But I'd have to change both equations to make my z's meet at 12. Or if I wanted to cancel out my y's, I'd only have to change one equation. So I like that option better. So since this is positive 10y, let's make this negative 10y, which means I need to multiply equation 2 by negative 10. So negative 10 times equation 2. So negative 10 times y is negative 10y. Negative 10 times negative 4z is positive 40z. And negative 10 times negative 16 is positive 160. And then we're going to add these 2 equations together, where my y's will cancel out. I get 37z equals 148. I hope that goes in there nicely. 4 times, I believe. Yeah, I think it goes in exactly 4 times. So if you divide by 37, we get z equals 4. Okay, I've got my first variable. Now remember, I can only get my next one by plugging back into my 2x2 system somewhere. I could use equation 4. I could use my original equation 2. In fact, I like equation 2. So let's plug in equation 2. Okay, so we're using equation 2 here. Oops. Let's change our color. So equation 2. And we're going to substitute into it y minus 4 times z equals negative 16. And we're substituting in our answer of 4. So negative 4 times 4 is negative 16. Add 16 over, and y is 0. I've got my second coordinate. So now to find x, I need to use either of my two equations that has x. So equation 1 or equation 2, they probably look about the same difficulty. Let's use equation 1. Again, it should work in all three systems. This x, y, and z should make all three equations true to be our solution. So it shouldn't matter which one. That's also a great idea to go back and check. 2x plus 2 times y plus 5 times z equals 20. So as I was saying, it's a great idea to check if you have the right solution. If you plug in the x, y, and z into all three equations, they should all be true statements. So let's substitute in. We're plugging in 0 for y and 4 for z. Okay, so crunching our numbers here. 2 times 0 is 0. 5 times 4 is 20. I get my 2x here. So 0 plus 20 is 20. Subtract 20 from both sides, I get 2x equals 0. And dividing by 2, I should get x equals 0. So if I have it right, my x coordinate 0, my y coordinate 0, and my z coordinate is 4. Okay. And if I want to check, I can go to my calculator, do our system solver again in my scratch pad, menu, algebra, solve system of 3 equations with x, y, and z, and plugging this in, 2x plus 2y plus 5z equals 20. Y minus 4z equals negative 16. And 3x minus 2y plus 9z equals 36. And hopefully we got the correct solution, 0, 0, 4.